hopefully yesterday's using properties of limits went okay. Today, 12.2, day 2, we're going to learn the easier way. So it's using direct substitution. So we are going to be able to use direct substitution to find limits along with how to find or deal with rational functions and limits. So first we're going to do direct substitution. And so there are two sayings that the limit of a polynomial function is the limit as x approaches c for p of x will just equal p of c. So you can use direct substitution and literally plug the number in to the equation. And for a rational function, it's similar. The limit as x approaches c of p of x over q of x equals p of c over q of c if q of c does not equal 0. So as long as for the rational function q of c doesn't equal 0, the limit can be this. If q of c does equal 0, that's going to come up in a minute. We'll look at what we can do. So we'll just do one example of direct substitution and one your turn, and then we'll go to these other. Okay. So example, and we say use direct substitution as possible if possible to evaluate, and if it's not possible, explain why. So if I look at, say, the limit as x approaches 3 of 2x squared plus 1 over x plus 3, for direct substitution, I don't have to break this up. I can just rewrite this as 2 times 3 squared plus 1 over 3 plus 3. 18 plus 1 over 6, so it is 19 over 6. So much simpler than using the properties, but if you see the properties, make sure you show the work. If we say the limit as x approaches -5, let's say the square root of x plus 3, if we plug in -5 plus 3, oh no, we get -2, and that is sad and undefined. So this is where we explain why. The limit does not exist. Square root of -2 is not a real number. Okay, so here's one your turn on here. Actually, I don't even know if you need a your turn, but go for it anyway. Limit as x approaches -3 of 2x cubed minus 5x plus 1. Give it a shot. All right, so we plug -3 in. Oh, I wrote cubed. Nice. -3 cubed is what? -27 plus 15 plus 1. -54 plus 16. I believe it's -38. There you go. So when you have a rational function, something funky might happen. I guess I'll go back to green. if I have a rational function, and if I have the limit as x approaches 5 of x squared minus x minus 20 over x minus 5, and if I plug 5 in, I get what? 5 squared minus 5 minus 20 over 5 minus 5. This turns into 0 over 0. If you get 0 over 0, this is the indeterminate form. Indeterminate form. And if this were 7 over 0, it would be undefined. The limit does not exist. There we go. But if it's 0 over 0, that means it's the indeterminate form. And then we manipulate the original problem. To find answer. And what I mean by that is you might be able to factor. You might be able to multiply by the conjugate. So, looking at this, x squared minus x minus 20 over x minus 5, oh, that looks like it's factorable. And sure enough, it's x minus 5 times x plus 4 over x minus 5. And then if you will recall back in the day, those simplify and there would be a hole here. And so this turns into the limit as x approaches 5 of x plus 4. I don't know why I'm writing a 5 or maybe a 3, which would be 5 plus 4 is 9. So our answer is actually 9 because there's a removable one. So I might as well give you one to try. And we would rewrite this problem. Yeah. Totally time. Only 7 minutes. So here's the your turn, and then we'll call it a day. The limit as x approaches 3 of x squared minus x minus 6 over x minus 3. So step 1, we're going to just do direct substitution and do 3 squared minus 3 minus 6 over 3 minus 3. No, 9 minus 9 over 0, which is 0 over 0. Kind of knew that was coming, didn't we? It's a indeterminate form. So now what I do is I'll rewrite this as the limit of x approaches 3, and I can factor x minus that to be x minus 3, x plus 2 over x minus 3. So we're looking the limit as x approaches 3 of x plus 2, which is 3 plus 2 is 5. So our final answer would be the limit as x approaches 3 of x squared minus x minus 6 over x minus 3 equals 5, even though at 3 it's undefined because there's a hole there. And if you were to support your answers numerically, it would get you there. Everything is coming back to this. That's it for today.